Whether you crave it or avoid it, caffeine is a powerful influence in our lives and has been an integral part of global culture for hundreds of years. It's as much a part of the morning ritual as brushing your teeth and making the bed. It even acts as the basis for meetings and business transactions. Experts say that UAE residents drink the equivalent of 3.5 kilograms of coffee, one of the most famous caffeine products, each year, nearly twice as much as people in any other Gulf country. Caffeine, in pure form, is an organic, naturally occurring, odorless, bitter, white, crystalline, xanthine alkaloid powder. Alkaloids are a diverse group of bitter-tasting, naturally occurring compounds that are found primarily in plants and contain basic nitrogen atoms. The basic property of alkaloids comes from the lone pair of electrons found in at least one nitrogen. Other well-known alkaloids include morphine, heroin, cocaine, and nicotine. Xanthines, on the other hand, are a group of alkaloids commonly used for their effects as stimulants, which is the reason why caffeine is considered the world's most widely used psychoactive drug to stimulate brain function and by far the most common stimulant. Caffeine in chemistry is called trimethylxanthine, and its molecular formula is C8H10N4O2.
What we have here is our caffeine. So the reds here denote oxygen. You've got carbon atoms represented by the black. These smaller white ones are hydrogen. And then the blue ones here, of which you've got 4, are nitrogen. So it's kind of the most common elements that make up so many what we call aromatics or organic molecules.
Its solid structure is composed of long hexagonal prisms that have a molar mass of 194.19 grams per mole. It has a melting point of 235 to 238 degrees Celsius and a boiling point of 178 degrees Celsius. Its solubility in water greatly increases as the temperature increases. Caffeine is moderately soluble in water at room temperature, but very soluble in boiling water. It is also moderately soluble in ethanol. Many organic molecules are interestingly basic, and caffeine solution is no exception, which is considered as a weak base. Caffeine is found in varying quantities in the seeds, leaves, and fruit of many plants, including coffee beans, tea leaves, cocoa beans, and kola nut, so it's found in a wide range of food products from coffee, tea, and chocolate to energy drinks and soft drinks. For plants, it acts as a natural pesticide that paralyzes and kills certain insects feeding on the plants. Caffeine is the most powerful xanthine in its ability to increase alertness, to put off sleep, and to increase one's capacity for thinking. It is medically useful to stimulate the central nervous system, heart rate, and respiration, and could also act as a mild diuretic, increasing urine production to flush fluid out of the body, which may adversely lead to dehydration. Caffeine can also be found in many weight loss pills to boost the metabolism, and is sometimes used to kickstart other medications. Here's what a caffeine molecule looks like. In your brain, there's a chemical called adenosine, shown here in red. As adenosine is created in the brain, it binds to adenosine receptors. This binding causes drowsiness by slowing down nerve cell activity. To your brain, caffeine, which is shown here in blue, looks just like adenosine. So your brain takes in caffeine instead of adenosine. Instead of slowing down because of the adenosine's effect, the nerve cells speed up. Caffeine's effect on the brain causes increased neuron firing. The pituitary gland in the brain senses this activity and thinks some sort of emergency must be occurring, so it releases hormones that tell the adrenal glands to produce adrenaline. Adrenaline is the fight or flight hormone, and it has a number of effects on your body. Pupils dilate, breathing tubes open up, the liver releases glucose for extra energy, the heart beats faster, and muscles tense. Caffeine allows brain cells to move at a quickened haste. So, caffeine blocks adenosine reception so you feel alert. It injects adrenaline, the fight or flight hormone, into the system to give you a boost. And it manipulates the production of dopamine, a pleasure neurohormone, to make you feel good. However, doctors have pointed out that caffeine's excessive intake can be harmful to the digestive and nervous systems. It can cause restlessness, headaches, stomachache and heartburn, heartbeat irregularity and increased blood pressure, and insomnia and the damaging effects on sleep quality. It can also cause the body to lose calcium, leading to bone loss over time, and some individuals may even develop a toxic reaction to it. Remember though, that caffeine shares some traits of those much harder drugs, including the ability to cause addiction. In this simplified experiment, we will extract caffeine from coffee. First, the caffeine will be extracted from the coffee into a non-polar organic solvent. Then, the solvent should be dried from any remaining water and is then removed by evaporation, leaving the slightly impure caffeine behind. The scientists in this video made around 6 cups of coffee and poured it into a flask. As mentioned before, the solubility of caffeine is greatly reduced at cooler temperatures, and so he is cooling down the coffee using ice. After cooling it down, he added sodium hydroxide to the solution. Sodium hydroxide acts as a Bronsted-Lowry base and accepts a proton from the caffeine. This process helps the caffeine move into the organic solvent to be used. After shaking the solution, he poured it into a separating funnel and added ethyl acetate. 2 layers form because the liquids are immiscible. Water is denser than ethyl acetate and so it sinks to the bottom of the funnel. We are more interested in the top layer because the caffeine is supposedly now in the top layer with the organic solvent ethyl acetate. There still is some water mixed with the ethyl acetate, and so we use a drying agent such as magnesium sulfate. He let it dry for a moment and then proceeded to filter the flask. And now to the last step, which consists of removing the ethyl acetate from the caffeine. The apparatus shown in the video is used to lower the pressure of the system and thus to lower the boiling point of ethyl acetate. Ethyl acetate evaporates and then condenses into another flask, leaving the caffeine behind. The idea here is to evaporate the solvent entirely. The light yellow you see is the caffeine. It's not fully white because of some color impurities from the coffee. If you are really interested in getting white crystals, you can purify it by using recrystallization or sublimation. And when weighing it with a balance, you will see that the 6 cups yielded 100 milligrams of caffeine. Whether you oppose the consumption of caffeine for its health risks or recommend that daily routine for its benefits, the fact stays that it's a major influence in our lives. and will probably continue to be for years to come.